Hi everyone, I just graded your lab procedure question on the take-home midterm, and I just wanted to discuss the ideas since they're fresh in my mind so I can kind of relay these concepts. I'm not sure if we'll have school, I assume no, so I wanted to at least present this video so you can make improvements for next time. So generally on that question, I hope you noticed that was similar to what we did, but notice that the question was different. It was about a bungee cord, not a spring or an elastic band. So a few of you were using that lab, which is what I wanted you to do to kind of help you derive and remember the procedure. But remember when you're answering this in the AP that you're actually addressing the question and not trying to make it exactly like the lab that we did. So just a warning on that. And that's what they'll do. They'll give you a question maybe similar to what we did, but not exactly what we did. So I have this actually at the last part right here. Pay attention to the question. Just do that. Oh man, I even have this spelled wrong. Pay attention, right? I just said pay attention, and that's spelled wrong. And kind of stemming on the pay attention to the question idea, a few of you mentioned to measure the elastic potential energy. Now, according to the question, you had to figure out the K constant and whether or not the bungee cord followed Hooke's law. So evaluating elastic potential energy was not part of the question. So if you did that in the AP, they would actually mark you wrong because it's extra work. You don't need that information. Now, that's something we did on our lab, and that's something we looked at, but specifically to this question, we make sure that you don't mention any extraneous information because they do dock points for that. So I was looking for a couple things in the lab procedure. You didn't have to go into great detail, although a few people did, which was fine. But the most important thing was to mention what Hooke's law is and how to measure it. So Hooke's law is a relationship of the force of the spring is equal to Kx. So kind of just saying that the Hooke's law is force of spring is equal to Kx. And that this is a linear relationship, meaning that if we were to graph the force of the spring and the elongation or the stretch x, that the final result would be a straight line. If the bungee had a straight line, then it was probably close to Hooke's law, and if it didn't, if it deviated or if the elasticity changed, then that would not demonstrate Hooke's law. Now, effective answers had both the equation and that explanation in it, and the AP readers will be looking for that explanation. So make sure you include the equations when you're discussing this. The other thing, you had to determine the K constant, and of course there are many different ways to do that. So as long as you explain one of the two major ways was either using the force spring is equal to Kx and graphing it and finding the slope of that line is K, or some of you just find the average value of K using the calculation. I accepted both responses, but you did have to discuss that. Make sure that you measure things in increments. I know some of you measured specific increments or just said increments, but you can't just put any mass systems on there. So most of you did this, but make sure you say when you add mass to the spring that you do it in specific increments. Make sure that all your units match. If you're measuring grams, that the weight has to be measured in kilograms. Those were a few things I saw on that as well. Make sure you explain your measurements. So some of you said you're going to measure the stretch of the spring. So you need to just elaborate that a little more. You could have done it the way we did it in the lab, was taking the measurement from the bottom of the floor to the spring and measuring that and then subtracting that from the initial length, or physically measuring from the equilibrium position to the elongation limit of the spring. You could have done that. Again, there's a few ways to do it, but make sure you explain how you got that. You are probably going to be required to draw a lab diagram. I didn't require it here for this, so that's why I didn't take off points, but if you did, kudos to you. But make sure when you do your diagrams, you must label them with the variables that you're measuring so that you get a visual of what the measurements are. So I'm actually going to demonstrate that in class because I think it's really hard for me to do that here, but just going to mention it right now. Include equations, which I've already said. There's always explanations of, let me take a step back here. So when you're all of physics is modeled through some sort of equation. So, we model how springs work through the force spring is equal to kx. As you pull more on it, there's going to be more force of the spring. So this relationship, this equation must be present in our explanation in any lab procedure that you're going to do. So make sure you tie this into a physics concept that has an equation to it. Also, not listed here, but I will list it. A lot of you said that we had to measure, had to plot the weight versus the x, which is correct, but you have to take a step further and explain why we can do Fg and net F, the force of the spring. But remember that when the spring is hanging down in its equilibrium position, the force of the spring down, force of gravity down is going to equal the force of the spring up. So mentioning that these are equivalent, which is why we can graph this and still call it this, is actually important as well. So you just need an extra sentence for that. But overall, everyone did very well. I wanted you to use the lab as a kind of a helpful tool of how to do that. But just remember, on the AP, you're going to have one question like this. So, and you're going to have a question where it might be a lab that you've done, so something like this, or it might be a completely new lab. So just be aware of these situations. Obviously, I tried to tailor the class to doing the labs that they test on, but they're always developing new things, so just be cautious and aware that it could be a new lab. And honestly, your gut instincts are usually the best ones, so I think you'll do just fine. But I hope you noticed online there was a little description of how to do this as well, how to answer AP questions under the take-home exam assignment section. There's a document that I wrote to help you with this too. So make sure you review that at some point because this relates to that. So next, everyone did fine in error. Error is usually not bad, but just to improve all of your responses, everyone did pretty good in this. The biggest source of error, of course, is measuring the distance. Although a meter stick is pretty good, it's not super accurate, and especially if you make any adjustments, or some people mentioned if you move the system or the stability of the spring moved, it changed the system. If it was oscillating, trying to keep it stabilized. The biggest thing was distance. So you had to specifically measure or say that measuring distance was difficult to do because that's the biggest source of error. How can you eliminate this? Multiple trials. And the biggest thing, a lot of you said use a digital recorder of distance, and that's fine, but think about what we actually have that does that, which is a motion detector. So don't make up devices. Now, I don't mean that like you're going to make up this whirly-do that measures distance, but try to tailor back to things that we've used in lab, like a motion detector. A lot of you said use a digital measuring system, so a motion detector is something that you can use. And if it doesn't actually exist, don't mention it. Now, I'm just saying this as a general statement. This doesn't have to do with the lab, but for example, if you said if you had to measure the density, you need to use a digital density meter. Well, unless that exists, don't mention it, okay? So just a warning on mentioning things in error. Another idea I liked from the students that responded to this was actually using a force sensor instead of actually calculating the weight. That was another really interesting idea, so that's fine. A few of you said human error, which is correct. But remember that when you're doing this in the AP, these are physicists. They know human error is a huge factor. They know that already, so you don't need to mention it. So just go straight to discussing the error. So just say the biggest error was measurements. And the physicists that are reading this assume that it is the actual experimenter, the human, that's doing this error. So you don't need to say human error. So just go right into discussing these things. And most of your ideas are pretty accurate. As long as they're logical and you measure and you mention something that is relatable to the equation, right? So just a quick step back. Distance is part of this equation and force. So either of these would have skewed the results. So if you said either of that. I'm going to just be silly here. If you said the acceleration measurements were the biggest error, clearly they're not part of the equation, right? That's not going to be a huge error. Plus, obviously, it's not part of our lab. But that the point is, look at the equation as a way to help you decide what's the important errors. It's the ones that you're graphing. In this case, was force and displacement. And just omit calculation errors. They're going to assume that you do them correctly. And just as a comment on that, so clearly we all make mistakes. And it's true. I make mistakes. You make mistakes in calculations all the time. But when you're talking about error in the experiment, they're asking, why can't you see the relationship perfectly? Okay, that's what they're saying. You know, what about the experiment causes you not to see a perfect straight line as we should? Because as you noticed in lab, we don't see these perfect things. So what is causing that? That's really what the comment on error is all about. Now, if you say you make a calculation error, well, that's your fault, not the experimentation's fault. So they want to know what is the experimentation's fault, not your fault. So just omit calculation errors altogether. I don't think most of you did this at all, but just making just a blanket statement with that. They're going to assume that you made the calculations right, whether or not you did. And it's okay. If you make a calculation error and you know it, just don't mention it in the lab analysis. So I hope this feedback is helpful. I made comments on your mastering physics. You should be able to go in to the actual question, and I believe if you click on it, it will give you comments on that question. So you can look at that, and if you need help with that, I can show you in class next time we have class. So hopefully this video was helpful, and I'll make a video for general comments of the next question.